All right, let's look at say hello to our little say hello to our little friend. Say hello to our little friend. Our little friend here is going to be looking at a couple of ideas important to properties of groups, uh, specifically if a group can have more than one identity element, and if more than one inverse element per element. So just two different things that kind of come up that are relatively easy to recover, if you will, and also illustrate some key ideas about proof and proof methods, and also some really cool connections now that we're talking about groups. So to answer, oh, I guess I'll call this one and two. So to look at number one, to kind of get us started. So the claim is okay. How do we want to say that? Let's say the claim is claim a group G had a unique uh, identity element. Maybe I should say maybe it has only a unique identity element, but should suffice to say that what I'm referring to is that for a group G, it only has an identity element. So the proof of this is pretty straightforward. And it's in these kinds of things, especially with uniqueness, the way that you usually would show something like this is to assume otherwise, and then by way of contradiction, show uh, or arrive at a contradiction. So we're going to start this by way of contradiction. Let's assume that assume G has two um, identity elements. We usually use E, which try not to confuse with the exponential, E1 and E2. Okay, so two identity elements where we would say E1 is not equal to E2. So they're both identity elements for the group G, but identity one is different than identity two. Okay. So then by straight computation, if we look at E1, and then I should have mentioned up here is the operation for G. So then E1 operating on E2, this gives us E2 since E1 E1 is identity for G. Okay, so E1 acting on E2 gives us E2 because E1 is the identity acting on acting or as the identity for G. Okay, and then likewise E1 acting on E2 again can also give us E1 since E2 is an identity, since E2 is identity for G. Okay, and so what you see here then is that in fact E1 is E2, but this is the contradiction that we were expecting to get. That we assumed that there were two unique identity elements for G, and then when we compose the or act on the two identity elements, we end up with E1 having to be equal to E2, which is against our assumption. So it does show then that so the answer to our first claim, our first question here is satisfied by our claim that every group G has a unique element for their identity. Okay. All right. So let's look at then the second equation here, or the second question, I should say. And if there is more than one inverse element per L. So this one, too, kind of like the previous one, right? We're going to talk about, I'm going to make the claim. Let's call it the claim. What do we want to say? A group G with operation star has for each element a unique inverse element. Okay. And again, we're talking about uniqueness here, so we're gonna follow that proof in a similar fashion. So by way of contradiction, assume element what do we call them? Elements of G A1 and A2. Yeah, I get it. A1 and A2 are unique or are inverses of an element A in G, where A1 is not equal to A2. Okay, then, okay, so what can we do with that then if that is the case? Well, in a similar fashion to the previous one, if we look at A1 acting on A2, since these two are inverse, since A2 is an inverse of A, then A1 acting on A1, A2 should give us the identity element, and which would then give us A1. Okay. And then in a similar fashion, A1 acting on A2. Okay. We can use the associativity of the group, since G is a group, and move these parentheses off of A1, A and A2 here. And then in a similar fashion, this is the identity at A2, which of course is A2. So here we have the same expression on both sides yielding two results. So it equals A1 and A2, which means then that A1 must equal A2. So if that is the case, then that is a contradiction to our, that's a symbol for contradiction. That is a contradiction to our assumption that A1 was different than A2 for the inverse element. And so here again, we show that indeed the claim is true, that every element in our group G with operation star has a unique inverse element, that there are not two elements of G that are simultaneously inverses of that element. Okay. All right. So I hope that was helpful, and I will see you in the next video.